Hey everyone, today we're going to go over the product property of exponents. So what this property says is that when you multiply powers with the same base, we add the exponents. So right here I have a little sample. So see how these two a's are next to each other with no symbol? So that means that they want you to multiply those a's. So one has an exponent of m and the other one has an exponent of n. So when I put them together, all I have to do is add those exponents. So this is the main property that we're going to be talking about today, the product of powers. Though there is another property that I need to mention because it will come up, and this is the negative exponent property. So anytime you have a negative exponent, you can move it to the denominator and it will become positive. So right here, a to the negative n power, if I move it to the denominator of this fraction, it is now a to the positive n power. So this is more of a side property, but it will come up when we start working on these. So let's look at that first example. I have b to the second power times b to the fourth power. So notice how they're the same base because they are the same variable, and that dot in the middle means that they want you to multiply. So according to the product property, we are going to add those exponents. So it would be b to the 2 plus 4 power. And when you do that addition, that gives you b to the 6th power. So that is the answer for that problem. Okay, let's look at our next question. So now I have x to the 4th power and x to the negative 8 power, and notice how they are both in parentheses. So this is just another way to show that they want you to multiply these two variables. So since they're the same variable, product property states that all I need to do is add those exponents. So 4 plus negative 8. And when you do that, that would give you x to the negative 4 power. So this is where that negative property comes in. Because that exponent is negative, I can move that down to the denominator of my fraction, and it would become positive. And since I have nothing to fill in the top, we would just fill that in with a 1. So that right there would be our final answer to this problem. When you simplify, you get 1 over x to the 4th power. Okay, now let's look at our next question. So again with the parentheses, so we know this means that they want us to multiply. I have 3 to the 3rd power times 3 to the negative 1 power. So this time their base is a number, it's the number 3. But the rule still applies. We're going to add those exponents. So 3 plus negative 1, which gives me 3 to the 2nd power. So this is 100% correct already, but I can simplify it even more. Because this is a number, I can type this in a calculator and get an actual numerical value for this. 3 to the 2nd power is the same thing as just saying 9. So our final answer here would be 9. Okay, next problem. 2 to the 3rd power times 2 to the 2nd power. So we're still doing the product property because they are multiplying. So let's add those exponents. 3 plus 2. So that would give us 2 to the 5th power. So again, this is already correct, but because it's a number, I can assign a numerical value to this. So if you type this into the calculator, 2 to the 5th power is the same thing as 32. Okay. Our next problem says p to the 2nd power times p to the 5th power times p to the 3rd power. So those parentheses, we already know that means that they want us to multiply all of these values, and all of them are the same variable. They're all p. So the rule still applies. All we need to do is add up those exponents. So I would be p to the 2 plus 5 plus 3 power. And when you add all of that up, you get p to the 10th power. So So that would be my final answer when multiplying those variables. Okay, let's look at our next one. So 5 to the third power times 5 to the negative 6 times 5 to the fifth power. So they all have the same base of 5, and they're being multiplied. That's what the dots mean. So product property states that all I need to do is add up those exponents. So this would be 5 to the 3 plus negative 6 plus 5 power. So if you add all those numbers up, that gives you 5 to the second power. Again, because this is a number, I know I can get a numerical value for this. So this turns into 25. So my final answer here, once I simplify, is 25. Okay, and one last example for today. This is my word problem that goes with multiplying variables. So it says find the area of a rectangle with a width of w to the fifth power units and a length of w to the seventh units. So just to help us picture this in our head, we have a picture of our rectangle right here, and they already labeled the length and the width for us. So the one thing that we have to consider here is formula for area of a rectangle. And area of a rectangle is just length times width. So we're going to fill in the length and the width part with what we know. So we know that the length is w to the seventh power. So even just looking at my picture. And my width is w to the fifth power. So according to the product property of exponents, since they are the same variable, they have the same base, all I need to do is add up those exponents. So this would be w to the 7 plus 5 power, which when you add up those numbers, gives us w to the 12th power. So the area of that rectangle is w to the 12th power. Okay guys, that's the basics of the product property of exponents. Tomorrow we'll discuss more complicated exponential expressions when it comes to this property.